Hello, folks. My name is Vitaly, and my talk is called Sprints Considered Harmful. Simple slide about me. I'm 38 years old. Out of these 38 years, I've been doing IT for 22 years. Started as a system administrator, then was doing 13 years of software development, then moved to management, and now I'm a developer advocate at Qase, and I'm also mentoring teams and engineering managers and team leads in IT. So I want to start my talk with saying that project management is dead. By the way, every slide has a QR code attached, and this QR code has a link which is relevant to the content of the slide. So feel free to capture it and to visit the links. So yes, there are quite a few reports, one of them called Chaos Report. The reports represent the status of our industry, and PMI and Chaos reports show that 70% of projects fail. And by saying fail, I mean that either budget is too much, not according to what's been planned, or the deadlines are missed. And one of the agencies in the US estimated that these failures cost around $260 billion. So it seems that the project management approach just failed. So why it's important will be clear a bit later. So what is the reason why project management is dead? Well, first, market changes all the time. If you read a beautiful book by Nassim Taleb, The Black Swan, you'll see even more occurrences of when market changes so significantly that companies go bankrupt sometimes. And there was also very interesting research done by Capers-Jones, where the scientists said that requirements in software development projects change quite often, essentially up to 2% per month. So if you have a project for 1 year with the requirements preset before the project has started, chances are that the requirements would change. 1/4 of the project of requirements will change. So 24% will change in a year's time. So no wonder why projects are failing. And the reason for that is that planning for uncertainty is impossible. We can't predict what's going to happen. So if we decide to start a project with a preset list of requirements, we can't just predict what's going to happen. And so our requirements will go obsolete. And also what's even more important, more interesting, that time pressure when the deadline is approaching diminishes quality. You've all seen these cases when the project deadline is like tomorrow and software development teams decide to cut on quality because the scope is fixed and we need to cut on something. We need to cut on testing, we need to cut on something else. And another interesting thing here is that quality, essentially, by definition, is just a match between the requirements and the outcomes. So whether something is of good quality can only be assessed when this object is used. So if I create a clicker, only my clients can say when they use this clicker if it's of good quality or not. So it means that we can't in advance say that a certain project will be of good quality. We need to deliver the project, and then the clients will say if it's of good quality or not, if this project helps them solve their problems. So this means that if we do something for a year or two with a preset list of requirements, we can make so much waste. We can go in a very different direction from what the client actually wanted. So that is why I think that projects are failing all the time. And I'm not alone in this observation. In 1993, Hirotaka Takeuchi and Ikujiro Nonaka published a paper called New Project Development Game, where they drafted what's now known as Scrum. They drafted an approach of delivering something quite often with cross-functional teams and small iterations. So they thought, right, if requirements change all the time, maybe it would make more sense if we delivered something to the client quite often, let's say in a couple of weeks or 4 weeks. And then the client could validate if this clicker or this app works as intended, as the client wanted. And then if we see that the product we're building is not what clients wanted, then we can inspect and adopt. We can see why we built something wrongly and change our process or change the direction of the development. So Hirotaka and Ikujira were thinking of the concept called cost of adaptation delay. So whenever we're building something for a long time, we delay building what's needed because we don't know in advance if the client wants this or not. But in this paper, they actually drafted this concept of deadlines for each iteration. So they introduced sprints essentially. In 1995, Ken Schwaber defined Scrum, the first draft of the methodology. He called it the iterative methodology, which improves on the spiral methodology, because spiral was a part of project management where they decided to have some iterations within the projects. So Schwaber introduced, as Hirotaka and the other Japanese scientists, he introduced the concept of cross-functional teams, where every member, where the team has enough knowledge and experience to build everything from start till end. He introduced the concept of constant inspect and adopt procedures every 2 months, every month, every 2 months, every 6 weeks, whatever your sprint is. And he drafted this time box concept, as he called it sprint, as in the sports. So he said that for every sprint there would be a deadline, and every sprint would have fixed scope. So you have to decide upfront what goes in the sprint. This looks like a project. Like every sprint, every small sprint with a sprint goal looks like a project. So every sprint, by the idea, by the definition, is a fixed period of time with clear predefined deliverable defined by the sprint goal, where you have to, once again, in advance, upfront, decide what the sprint would contain. And after you've done something in this sprint, after you've completed this sprint, you start inspection and adoption process by the means of retrospective. So it does look like the big project was split into small projects. So what is the problem here? Why do I call sprints a harmful procedure? Well, to me, the first reason is that sprint, similarly to projects, they have fixed time and fixed scope. So we have a glass here on the screen. And every single problem we're trying to solve when we're developing code is unique and unknown in advance. So we don't know how much time it would take us. We don't know the amount of effort that it would take us to solve a certain problem. So my question here is, how many unknowns can fit in this glass? How can we actually decide what to take into our sprint? So hence, estimations are emerged. So in order to understand how much we can fit in the sprint, we need to estimate the problems. We need to estimate user stories or tasks or problems we're solving. So what happens if our guess, if our estimation is wrong? There's quite a popular question on the internet, what to do with tasks if we can't feed them in the sprint. So let's say it's Thursday and tomorrow the sprint ends. Tomorrow is the deadline for the sprint. So what do we do if certain tasks are not complete? Should we move them to the next sprint? Should we abandon them? What should we do? This question is so popular in the internet that it means, I think, at least to me, it means that the problem is real. The problem that we can't in advance, we can't upfront say how much we can fit in the glass, how much we can fit in our fixed scope. That's the same reason why so many projects fail, because they tried to predict in advance how much uncertainty they can resolve within a fixed period of time. So what if our guess is wrong? What do we do with that? That's a hard question for the sprint concept. So fixed scope of the sprint requires estimation or guessing. We can only say how much time a certain problem takes to resolve when we finish it, when we complete the problem, when we resolve the problem. Only then we know for sure, for certain, how much time it takes us. Even if the problem that we are about to solve now looks similar to what we've done in a different product, our product is unique. And maybe our code is bad, maybe our code is good, maybe one of the team members is sick, maybe something else happens. So we are just guessing how much time it will take us. And this QR code links to my talk on estimations. Please watch it as well. It's going to be interesting. And so the lack of time imposed by the deadlines reduces quality. As I've said, if it's Thursday today and we need to complete our fixed scope by Friday, we're going to skip on testing. That's quite an unusual thing to do. And I would say that the concept of technical debt, arises from this approach, from the approach of fixed scope and time, where we can't have enough time to do things right. And what's worse is that low quality does not only negatively affects the products we are building, negatively affects the reputation of our company, but it also destroys professional ethics of the developers and destroys their motivation. I'm sure you've seen people who are so tired of producing bad code, or they even call it shitty code. So people are often very tired of producing bad quality stuff. And when people are tired of something, they lose motivation. You can only stimulate people so far. You can't make them enjoy stuff. And there are plenty of studies saying that when people and developers are enjoying what they're doing, when they're happy at work, they are much more productive. So low quality induced by the lack of time not only affects negatively the product, but also negatively affects motivation, performance, and happiness of the engineers. Also, when we are guessing something, when we are guessing that we will be able to finish tasks in this sprint, the set of tasks in this sprint, we commit to this. Every single guess of the estimation is perceived by management, in most of the cases, as a promise. So when a manager asks you, the developer, how much time would it take you to run this, to complete this task? And you say, well, 3 days. Manager eventually thinks that in 3 days' time, this task would be done. And once again, he relies on your estimation as if it is a promise or commitment. And when people commit to something, either voluntarily or by the order of management, they are stressed that they won't be able to finish things in a proper way on time. And when there is stress, there is burnout. There are multiple studies in the US and in Europe showing how burnout negatively affects companies. Turnover costs, when people leave and have to be rehired, are like really high. I've seen studies saying that in software development, it takes from 6 to 12 months worth of a salary of a developer to replace a developer. So whenever you have sprints and deadlines, you introduce more stress, leading to more burnout, leading to people leaving your team. The average tenure, the average time that developers spend in a company usually is just 1 year or year and a half. So every 18 months, you are paying from 6 to 12 months worth of salary to replace a developer. And I'm not even counting the impact that a developer could cause, the good impact the developer could cause if he stayed or she stayed. So managers always track this guesswork. There is a concept called velocity. So teams are not static, mechanistic machines. Teams comprise of people. And so people can be sick, people can be tired, people can be not interested, people can have issues at home, whatever. So their guesswork cannot accustom for that. Their guesswork cannot work with this. We suck at estimation. We can't guess properly. And so whenever we start guessing, managers will start tracking our commitment. Managers will start tracking our velocity. and they will try to optimize for the velocity, to increase the velocities. They will think that a team needs to improve every single month, every single year. Team needs to become faster, while it's not the case. People can only improve to a certain level of experience. And then another thing with sprints that I dislike particularly is that inspection and adoption phase starts only after we delivered something, only when the sprint is completed. So people start getting used to that whenever they see a problem, they need to wait with this problem till the sprint ends, and only then they can even discuss the problem. So they have to crunch till the end of the sprint, knowing that certain issues are in our processes, and only then they can discuss it, and only then maybe potentially they can improve it. I usually ask Scrum Masters of all sorts, show me the amount of improvements you've done after the inspection and adoption phase. If your sprint length is 2 weeks, you have how many inspection and adoption phases? 26 or more a year. And so you have to at least have 26 good improvements done in your processes. I rarely see that. And I can explain why, because usually sprint is being planned with a product manager. And so the product manager is not usually that interested in improving the system. Usually product managers are only interested in delivering more features. So essentially, people see that they will have to wait to even discuss the problem till the retrospective. Then maybe, potentially, just maybe, the problem will be resolved, and maybe not. So this gets our work converted into ritual work, where you don't think, you delay thinking. There is no Kaizen. This QR code links to explanation of what Kaizen is. Kaizen is a very simple approach. If you see a problem, you fix it. But Kaizen cannot coexist with sprints, because sprints are immutable with fixed scope. So you can't stop your sprint work and improve something. You have to wait. And this is waste as well. In lean manufacturing, something which is not working called waste. So you have to live with waste until you are allowed by the Scrum Bible to resolve the issue. I'm not sure why this is a good idea in the first place. So with all this negativity, let's say, with all this criticism, what can we do instead? Well, I propose normal flow, something what I call normal flow. So whenever we have a backlog of things to do, we as a team can take one problem, solve it. We don't need to have estimations. We don't need to have deadlines. If we are seeing that we are stuck with this problem, we can report to our product manager and tell them, see, we are stuck. Do you think we should proceed? Or shall we stop here and take another problem and just get rid of this one? Maybe it's worth it to do so. Whenever we complete something, but it means that whenever we are certain that we are ready to show something valuable, we show it. If the client is not ready to see us and talk to us every 2 3 4 days, we can collect a few artifacts and show the client when they're ready, once a week, twice a week, once per 2 weeks, whatever. And whenever we receive feedback from the client, if the things we've built are good or not, we can act upon this feedback. We can either improve something or rebuild it or discard it. And we can always rationally decide whenever we receive a feedback, do we need inspection and adoption phase in our processes? Maybe the client said that, well, you know, even though you tested something, it failed for me 5 times out of 10. Then it means that our quality assurance process is bad. And then we can rationally decide to invest time into improving the QA process that we have. So this one-piece flow, where the whole team takes one problem and resolves it, is proven to be faster and better. Even though the individual utilization of each employee, of each developer or QA specialist or designer is much lower, the overall lead time or time to market for the feature is much higher. And if we want to be agile, if we want to deliver fast and act upon clients' feedback fast, we need to minimize our lead time. So this one-piece flow approach is, I would say, truly agile. So I advise you try it. Of course, this will not work in the situation where time constraints are external to you. So even though I said that project management is dead, it is still used by outsourcing companies. It is still used by companies who work for the government. Because if you want to work for the government, you need to play this tender game where you win a contract with a fixed price and fixed scope, and then you need to work with it. So I'm only talking about product management here, where you are building the products that clients are using. And if you are doing that, try my approach. I think you'll like it. I've also attached a QR code with the list of books that I recommend every engineering manager or CTO to read. For this particular talk that I'm giving now, I would suggest you read the following theories: systems theory, which is very nicely put by Akov; theory of constraints, Deming and Detmer; Taleb book on Black Swan. This book is about market changing all the time; and game theory by Axelrod. Game theory is required to see. Understanding of game theory is required to rationally design how people interact in the company. So I think I'm done here. Here is my company Twitter, my Telegram, my email, my GitHub, and my company blog. Feel free to contact me. I'm always keen to help and consult. Well, thank you.